Hello everyone, welcome to the lecture again. In the last class, we discussed the velocity and acceleration of a particle in Cartesian coordinate and planar polar coordinate system. Today, we are going to discuss the spherical coordinates. So, spherical coordinates, let us say we have the x, y and z axis. Let us say there is a point P whose coordinate is let us say r, theta and phi, where r is the distance of this point from the origin, theta is the angle that it makes from the z axis and phi is the angle that its projection on y x plane makes with the x axis. So, this angle is phi. Now, let us write down the r, theta and phi, so in terms of x, y and z, and these are called the transformation equation. So, this is how we can transform from Cartesian coordinate to spherical coordinate. So, x is equal to, you can see the figure. So, x is the projection of r on the y x plane. So, this is r sin theta and then its projection along the x axis. So, therefore, it will be cos phi. Similarly, y will be r sin theta sin phi and z will be r cos theta. Now, vector r I can write down as xi plus yj plus zk, and now since I know what is x, y and z, so therefore r vector can be written as r sin theta cos phi I plus r sin theta sin phi j plus r cos theta k. Now, let us calculate dr vector over dr. This should be a unit vector in the r direction, because in Cartesian coordinate also you note that dr over dx was I, dr over dy was j and dr over dz was unit vector along z direction, that is k cap. So, dr over r will be sin theta cos phi I plus sin theta sin phi j plus cos theta k cap, and dr over dr, its modulus should be 1. Let us see that it is square root sin square theta cos square phi plus sin square theta sin square phi plus cos square theta. Now, from here you can take sin square theta common, then it will be cos square phi plus sin square phi, that will be 1, and then you will get sin square theta plus cos square theta, that will be 1. Therefore, this is also 1, and therefore, this is our H1, and r cap is this, it is sin theta cos phi I plus sin theta sin phi j plus cos theta k. Now, let us calculate del r vector over del theta, that should give you a unit vector in theta direction. So, our vector r is this, which is r sin theta cos phi I plus r sin theta sin phi j plus r cos theta k. So, we are interested in finding out del r over del theta, that should give you the unit vector in theta direction. So, it is r cos theta cos phi I plus r cos theta sin phi j minus r sin theta k. I can take r as a common factor. So, it is cos theta cos phi I plus cos theta sin phi j minus sin theta k, and you can see that del r over del theta, its modulus comes out to be r. So, again you can do square root this square plus that square plus that square, and then you have r square, that comes out to be r. Let us call this as h2 scale factor along theta direction. Therefore, our unit vector theta cap should be this quantity, which is cos theta cos phi I plus cos theta sin phi j minus sin theta k cap. Now, let us find out del r over del phi. This should give you a unit vector along the phi direction. So, again let us use this and differentiate it with respect to phi. We have minus r sin theta sin phi I plus r sin theta cos phi j. I can take r sin theta as a common factor, then we get minus sin phi I plus cos phi j, and you can see that del r over del phi mode is r sin theta. So, therefore, this is our h3, and whatever is left is the unit vector along the phi direction. So, phi cap is minus sin phi I plus cos phi j. Now, we can write down the infinitesimal displacement vector dr in terms of h1, h2, h3 and u1, u2, u3, because in spherical coordinate system these are our u1, u2 and u3. Therefore, the infinitesimal displacement dr will be h1 du1 u1 cap plus h2 du2 u2 cap plus h3 du3 u3 cap, and h1 is 1, du1 is dr and r cap, plus h2 is r, u2 is theta. So, this is d theta theta cap plus h3 is r sin theta, and u3 is phi. So, d phi phi cap. Therefore, the infinitesimal displacement vector in spherical coordinate becomes dr r cap plus r d theta theta cap plus r sin theta d phi phi cap. Now, let us look at the differential area element. This is h1 du1 and h2 du2, and its direction is in the u3 direction. So, it becomes 1 dr and r d theta. So, this becomes r dr d theta. Now, let us look at differential volume. So, we know that it is h1, h2, h3 du1 du2 du3, and this becomes 1 r r sin theta dr d theta d phi. So, this becomes r square sin theta dr d theta d phi. Now, we are going to find out the expression for the velocity and acceleration in a spherical coordinate system. But as you know that as the particle moves, then the unit vector along the r theta and phi direction are going to change. Therefore, we have to find out how r cap, theta cap and phi cap changes with time. So, let us calculate what is dr cap over dt. This will be d over dt, and r cap, the expression for r cap we already know, it is this. So, it is sin theta cos phi I plus sin theta cos phi I plus sin theta sin phi j plus cos theta k. Now, I, j and k cap, they do not change with time, therefore, we can take them outside. So, it will be minus sin theta sin phi dot plus cos phi cos theta dot into I plus sin theta cos phi dot plus sin phi cos theta dot j plus minus sin theta dot k cap, and let us collect the term of theta dot. So, it will be cos phi cos theta I plus sin phi cos theta j minus sin theta k cap plus phi dot minus sin theta sin phi I plus sin theta cos phi j. Now, this term in the bracket is nothing but theta cap, you can see here, and we have phi dot. I can take sin theta as a common factor, and then whatever is left is phi cap. So, we have phi cap. Therefore, r cap dot becomes theta dot theta cap plus phi dot sin theta phi cap. Let us call it equation number A, and let us now calculate what is del theta cap over del t. Okay. So, this will be d over dt theta cap, okay, and this is the theta cap. So, it becomes cos phi cos theta I plus sin phi cos theta j minus sin theta k, and it will be minus cos theta sin phi dot minus cos phi sin theta dot I plus cos theta cos phi dot minus sin phi sin theta dot j minus cos theta dot k cap. And now, I can collect the coefficient of theta dot and phi dot. So, the coefficient of theta dot will be minus sin theta cos phi I minus sin theta sin phi j minus cos theta k plus phi dot minus sin phi cos theta I plus cos theta cos phi j. Therefore, theta cap dot becomes, so this quantity over here is nothing but minus r cap. So, you can see this. So, therefore, I can write it down as minus theta dot r cap, and here I can take cos theta as a common factor, and then whatever is left is phi cap. So, it becomes phi dot cos theta phi cap. Let us call it equation number P. Now, let us calculate d phi cap over dt, and it is d over dt. The value of phi cap was minus sin phi I plus cos phi j. Therefore, this becomes minus cos phi dot I minus sin phi dot j, and I can take phi dot or minus phi dot as a common factor. So, this becomes cos phi I plus sin phi j, and I will show you in a second that cos phi I plus sin phi j is equal to sin theta r cap plus cos theta theta cap. Therefore, this becomes minus phi dot sin theta r cap plus cos theta theta cap. Therefore, phi dot becomes minus phi dot sin theta r cap minus phi dot cos theta theta cap. Let us call it equation number C. Now, let us come back to this identity. For that, let us look at the right hand side. The right hand side I can write down as sin theta, and the value of r cap I know. Okay, r cap was sin theta cos phi I plus sin theta sin phi j plus cos theta k cap. So, we are solving this side plus cos theta, and theta cap was cos theta cos phi I plus cos theta sin phi j minus sin theta k cap. Okay. Now, this sin theta get cancelled with that cos theta because there is this sin theta and cos theta multiplication. Therefore, we get I into sin square theta cos phi plus cos square theta cos phi plus j sin square theta sin phi plus cos square theta sin phi, and this becomes this because you can take cos phi as a common factor. So, it is sin square theta plus cos square theta, which is 1. So, it becomes I cos phi plus here also you can take sin phi as a common factor. So, it becomes sin square theta plus cos square theta, which is again 1. So, we get j sin phi. So, now we have find out the time derivative of the unit vectors along r direction, theta direction and phi direction, which we are going to use to find out the velocity and acceleration in spherical polar coordinates. So, let us first look at the velocity. V is d r vector over dt, this is d over dt, vector r is r cap, and this I can differentiate. So, this becomes r dot r cap plus r dr cap over dt. So, this I can write down as r dot r cap plus r. Now, dr cap over dt I have already calculated from equation number A. So, let us use that. So, we have theta dot theta cap plus phi dot sin theta phi cap. This is from equation number A. Okay. So, this becomes r dot r cap plus r theta dot theta cap plus r sin theta phi dot phi cap. This is the velocity in spherical polar coordinates. Okay. So, as you can see, this is the velocity along r cap. So, this is radial velocity, this is the velocity along theta cap direction, and this is the velocity along the phi cap direction. Now, let us calculate the acceleration. So, the acceleration is r double dot. Okay. R double dot is equal to, so let me take this equation, let us call it equation number A, and find out its derivative. So, this is first function, this is second function. So, its derivative is first function as it is, derivative of the second one, and then second function as it is, the derivative of the first one, and similarly for the second and third term. So, we have plus r theta dot theta cap dot plus theta cap r theta double dot plus theta dot r dot plus we have this term now. So, it is r sin theta phi dot phi cap dot plus phi cap phi double dot plus phi dot phi cap r cos theta theta dot plus r dot sin theta. Now, let us put the value of r cap dot, theta cap dot and phi cap dot from equation number A, B and C. So, we have r vector double dot equal to r dot, the value of r cap is theta dot theta cap plus phi dot sin theta phi cap plus r cap r double dot plus, now let us put the value of theta cap dot. So, we have r theta dot, theta cap dot is minus theta dot r cap plus phi dot cos theta phi cap plus we have theta cap r theta double dot plus theta dot r dot plus we have r sin theta. So, r sin theta and we have phi dot. So, let us put that phi dot also outside, phi dot, and the value of phi cap is minus phi dot sin theta r cap minus phi dot cos theta theta cap plus we have this term. So, it is r sin theta phi cap phi double dot plus the last term phi dot phi cap r cos theta theta dot plus r dot sin theta. Now, we can collect the coefficient of r cap, theta cap and phi cap. So, we have r double dot equal to r cap, its coefficient from this equation is r double dot minus r theta dot square minus r sin square theta phi dot square plus the coefficient of theta cap dot is 2 r naught theta dot plus r theta double dot minus r sin theta cos phi dot square plus the coefficient of phi cap is 2 r dot phi dot sin theta plus 2 r dot phi dot theta dot cos theta plus r sin theta phi double dot, and this is our master equation to calculate the acceleration. So, here the first terms gives you the acceleration along the r cap direction, this gives you the acceleration along the theta cap direction, and this term will give you the acceleration along the phi cap direction. With this, let me stop here. See you in the next class. Thank you.